Okay. So a district medical officer seek to estimate the proportion of children, in the district receiving appropriate childhood vaccination. उसको ये देखना है कि what proportion of children are receiving appropriate childhood vaccination. Now, assuming a simple random sample of a community is to be selected, how many children must be studied if the resulting estimate is to fall within 10 percentage point of the true proportion with 95% confidence? तो जो ये 10 है, this 10 is the margin of error, half width delta, okay, and level of significance is 95%. ठीक है, तो अगर आप फॉर्मूला दे, if you will see the formula for selecting this n, calculating this n, this delta is 10, ये तो 10 हो गया, okay, z alpha by 2 1.96 हो गया because 95% confidence है, but we should also have an idea कि p क्या होगा, इसी p को estimate करना है. Now this is a very quite tricky. So what we do here, that we take the value of p as 0.5 because for this p the sample size is largest. देखिए हमें अगर p के बारे में कुछ भी आइडिया नहीं है, what proportion of children are properly vaccinated, अगर if we have any idea from the past study or from any other study, we can take the value of p from that study, quoting that reference. But as a researcher, if you do not have any idea about p, what we do, we take p is equal to 0.5 because for this value of p, our sample size will be maximum statistically. So hence we choose p is equal to 0.5 when we do not have any idea about p. When choosing p is equal to 0.5, it will provide enough observation irrespective of the actual value of the true proportion. Now we just simply substitute the value of 1.96. Delta is 0.10 because it is 10%, and p ki value 0.15, and when we'll solve it, we are going to get 97. So we have to randomly select 97 kids from the community to check that whether to estimate the proportion of children who are getting appropriate childhood vaccination. Okay. Now take this another example also. A local health department wishes to estimate the prevalence rate of tuberculosis among children under 5-year age in its locality. ठीक है, तो CMO साहब को चाहिए कि prevalence, she want to estimate the prevalence of tuberculosis in a district. Okay, now how many children should be included in the sample so that the rate may be estimated to within 5 percentage point of the true value with 99% confidence. अभी देखिए यहाँ पे हमारा ये 10 की जगह 5% हो गया और हमारा कॉन्फिडेंस लेवल 95 की बजाय 99% हो गया, बिकॉज इट इज अ केस ऑफ ट्यूबरक्लोसिस, ये फैलता है. सो वी हैव टू बी वेरी मच प्रिसाइज about the prevalence of such disease. Okay, so using the same formula, p is equal to 0.5, delta is our 0.09, हमारा जो n आया है वो 666 children आया. सेम फॉर्मूला पीछे वाले फॉर्मूले में आप डालेंगे, you are going to get this. Now if you can say if the rate does not exceeds 20%, okay, अगर कोई कहता है कि ये 20% से ऊपर नहीं हो सकता, because here we are taking p as 0.5, but if somebody says that कि ये prevalence 20% से ज्यादा नहीं हो सकता, so instead of taking p is equal to 0.5, we can take p is equal to 0.2. For just changing from 0.5 to 0.2, it's the n sample size is 4 to 7. Now if studying this many children is unrealistic with respect to the time and money, the investigator should lower their requirement of confidence perhaps to 90%, and delta is 0.05 and p is 0. तो जो 99 था इसको 90% कर दीजिए and your sample size will be only 174. In this way you can recalculate your sample size, but ऐसे नहीं कि कहीं से भी उठा करके कुछ भी वैल्यू डाल दें. You should have proper justification behind putting any value for calculating the sample size, or you have to document it properly. कई रिसर्च आर्टिकल पढ़ते हैं हम खुद ही, मुझे मिलता ही नहीं कि सैंपल साइज कैलकुलेट करने के पीछे अगर p की वैल्यू 0.5 या 0.2 या 0.7 whatever the value of p is being taken, आपके पास सॉलिड प्रूफ होना चाहिए कि आपने why you have chosen such p value. ओके, ये आपका स्टडी है तो आपको बहुत मेहनत करनी है सैंपल साइज कैलकुलेट करने के लिए. मेहनत मतलब फॉर्मूला इज वेरी सिंपल, लेकिन विच वैल्यूज यू आर गोइंग टू इनपुट, वो कहां से लिया उसको नोट करके रखना है, उसका रेफरेंस होना चाहिए. सो इट माइट seems more reasonable in the same example to require the estimate of p to fall within 10% of the p rather than जैसे अभी डेल्टा हमने 0.05 लिया, for that you can choose delta 10% of p rather than delta is equal to 10. Now this is very important. 10% of p, or you are going to take it 10%. Okay. So if the true proportion vaccinated was 20, the strategy used in the above example would result in estimate which is fall between 0.10 and 0.30. अगर true proportion जो है vaccinated नहीं होगा, उसका हमारा जो tuberculosis का जो है, if it is 0.20, so absolute difference जो होगा 0.10 and 0.30. In 95 out of 100 sample drawn from this population. Instead, if we require our estimate to fall within 10% of 0.20, okay, then we would find that 95 out of every 100 sample would result in an estimate between 0.18 to 0.22. Okay, क्योंकि 10% of वो 0.2 ही होता है, तो 20 से 2 ऊपर, 20 से 2 नीचे. Okay. So first calculate this D and then proceed. So yeah, up to now we are just focused on estimation. हमारा problem था हम estimate करना चाहते हैं. अगर हमारा problem हो गया कि we are in the process of testing a hypothesis, then sample size formula calculation, it is quite different, है ना? So take this example. If you want to test the hypothesis that the average height of the college student is 140 centimeter, against that it is not equal to 140 centimeter, and the standard deviation is sigma, it is 30. पहला problem क्या था? जो पहला example which I have taken, in that you simply want to estimate the average height, but now the now the problem is different. Problem is that now you want to test if mu is equal to 140 centimeter against mu is not equal to 140. Okay. So for this, you can see that the confidence interval x bar plus minus z alpha by 2 sigma by under root n. This is your confidence interval. Okay. And the acceptance region will lie between 134.12 to 145.88. Now, what is the meaning of it? This is that if you just take a sample, okay, you just take a sample of size 100 and calculate the mean. If the mean is going to lie in these two, 134 to 145, then you will say that your this 140 centimeter, it is true. Okay, आप जो कह रहे हैं ना ये 140 centimeter, ये null hypothesis is true if your mean is going to lie in this interval. But if you change the level of significance from 0.05 to 0.01, so ये 134 से 132 and 140. So it will just so if your mean is going to lie in this interval, then you will say that okay, the null hypothesis is true. Now this is what is being calculated from same confidence interval formula. Okay, this is the logic behind understanding that what is the confidence interval. Now this is the test statistic which we are going to use. We are going to use the test statistics based on the t-test. Okay, we are going to test the mean. So the sample size calculation formula is being derived on this particular. I'm not going to explain that how this formula is being derived because you can see from this particular slide beautifully, the formula for sample size comes out to be this, n which is equal to z alpha by 2 plus z beta. This is the power of the study. Sigma by delta ka whole square. What is the difference? Usme z beta nahi tha. In the previous formula, we do not have the power of the study. Okay, we have just z alpha by 2, sigma by delta ka whole square, if you remember. Okay. So, for example, if an experimenter is planned to test the hypothesis that 32 calorie versus the children at the time of lunch, whether they are just having this much calorie or not, we want to test this. The data is assumed to be the normally distributed, the standard deviation of 400 calorie. What sample size is required for this level of significance and this much power? And clinically significant difference of 300. Just substituting these value, we are going to get the at least 19 students must be selected into the data for testing this hypothesis. तो statistician के पास जब आप जाएंगे, ये सारी values वो आपसे पूछेगा, and the most important value which he will ask you for this delta, this clinically significant difference. Okay. And another value which he will ask you is the sigma. What is the standard deviation? जो unit आप measure कर रहे हो उसमें standard deviation कितना है? Most of the time you do not have the answer for these two. तो वो करता है होता है क्या कि statistician अपने मन से कुछ value भर देता है. This is wrong. This is your baby, so you have to tell that what is the value of delta. कितना difference जो है वो clinically significant होगा. Okay, that information you have to give. कि hemoglobin level 11.11 हो, चाहे 13 हो, चाहे 9 हो, मेरे लिए कोई difference नहीं है. मैं I can proceed for the surgery or for the procedure. Okay, लेकिन वो 11 से 9 या 10 तक आप tolerate कर सकते कि 3 का difference you can tolerate or not, that you have to decide. वो नहीं कि सैंपल साइज आपके हिसाब से लाने के लिए वो डेल्टा की वैल्यू अपने हिसाब से रख रहा है. दैट इज नॉट रॉन्ग प्रैक्टिस वी आर डूइंग. इसीलिए इसकी नॉलेज आपके पास होनी चाहिए कि दिस डेल्टा, दिस इज वेरी इंपॉर्टेंट. Okay.
Sir,
so
one question. Should I ask you now only?
Yes, you can.
Many times we don't have a sigma or delta. Then can we use from our own pilot study?
Yeah, I am coming to this. ये तो आपने पहले ही जवाब दे दिया. मैं बताने वाला था ये. Yes, we can do that.
Sorry.
Yes, you are right. Very good. Okay. So this is another example. Just I have shown it here. Okay. Now factors that affect confidence interval. जब हम n का formula confidence interval से निकालते हैं, जहाँ पे z beta is not there. So this margin of error, standard deviation, and confidence level z alpha by 2. These three value, it affects the sample size. Obvious ही बात है, अगर standard deviation ज्यादा होगा हमारे डेटा में, we need more sample. अगर हमारा margin of error ज्यादा होगा, we need less sample. If we want more precise estimate, we need more sample. So it is quite justification whether the interval is one-sided or two-sided. So this is also very much important. I didn't explain it, and the factors that affects the formula based on testing of hypothesis. Only difference is that z beta is sitting over here. because our objective is not different. So the effect size delta, you can see mu naught minus mu 1. What is the, how much difference between the null hypothesis and alternative hypothesis that we can tolerate? Again, standard deviation and alpha and power. Now, very important, adjusting the sample size. Sometimes what happens, we calculate the sample size and start going for collecting of the data, but we have some non-response and loss to follow. From patient, we recruit the patient, and then we just have non-response. So we should incorporate these, that at the end of the study, at least we have 10% of the non-response. पहले से हम उतने patient को ही recruit करके रखते हैं, है ना? If the estimated sample size is 100, then expected non-response loss to follow bias is 10. Okay, so simply हमें last में 100 चाहिए, तो we have to start with x. हमको कम से कम x से start करना है, such that x minus loss to follow up is 10% of x, and when we'll solve this for x, so we are going to get 112. तो कम से कम 112 लोगों से हमको शुरू करना चाहिए. So this is one way of adjusting the sample size. Another way of adjusting the sample size is design effect. As I told you that all the formula which I have discussed for calculating the sample size is based on the assumption is that data is drawn randomly from the population. It is a random sample. But if your data is not the random sample, then you have to use this formula design effect, that what is the standard deviation under another study design divided by a standard deviation into the simple random sampling. So usually, in a nutshell, you should multiply your sample size by 1.5 or 2 or 3 if you are not using a random sampling. So it will just adjust the design effect. Okay, what are the cautions? Inappropriate effect size, I already discussed, इसका बहुत ध्यान रखना है आपको. Second, inappropriate or inaccurate standard deviation. इस sigma आप अपने मन से नहीं डाल सकते. You should have a solid proof that what is the standard deviation of the measure violation to the assumption, whether your data is normally distributed or not normally distributed. And analysis method, model for sample size different from the method or model used in the data. आपने sample size calculate करने के लिए जो formula use किया वो तो कुछ और था, analysis के लिए जो formula use किया वो कुछ और था. So this is very common, which I am personally observing. It should be avoided. Deviation from the study design से deviate हो गए. Okay, and fail to anticipate the effect of lurking or covariate. Okay, so this is a part of the very important. अगर आपने lurking variable और covariates को नहीं ध्यान में रखा, उसको anticipate नहीं किया, so all your studies are being going to the.
Sir, what is that lurking variable?
Yeah, lurking variable is the variable which is going to affect your outcome. ठीक है. अभी जैसे हम बताएं, for example, you can see कि पेशेंट एडमिट हुआ और पेशेंट की कोविड के पेशेंट एडमिट हो गए और कोविड के पेशेंट का आप डिस्चार्ज का वो कर रहे हैं कि उसमें से डिस्चार्ज एट द टाइम ऑफ डिस्चार्ज whether the patient is discharged or the patient is died. Okay, this is the outcome on which you are going to study. तो आपने कहा कि ठीक है, हमारे हॉस्पिटल में 80% पेशेंट डिस्चार्ज हो गए, बहुत अच्छा काम किया. लेकिन दूसरे हॉस्पिटल में तो 50% डिस्चार्ज हुए या 30 मतलब जिंदा जो हैं वो जो लाइव हैं वो केवल 50% है. तो आप कहेंगे कि ये हॉस्पिटल बहुत अच्छा है जिसमें 80% डिस्चार्ज हुए. क्वेश्चन ये है कि आपने क्या लर्किंग वेरिएबल का ध्यान रखा कि जो पेशेंट जो उस हॉस्पिटल में गए थे उसमें से हाइपरटेंसिव शुगर वाले ज्यादा थे कि इसमें ज्यादा थे? अगर दोनों में प्रोपोर्शन सेम है तब तो आपका कंक्लूजन सेम है कि इस हॉस्पिटल में ज्यादा अच्छा काम हुआ, ज्यादा मेहनत की है. बट इफ यू डू नॉट टेक केयर ऑफ दिस लर्किंग वेरिएबल तो आपका जो कंक्लूजन है वो गलत हो गया. तो दिस इज अ वेरी एग्जांपल बाय व्हिच यू हैव टू understand the importance of lurking variable. I hope it is clear.
Yes, sir.
Okay.
We are comfortable with the professional language.
I didn't understand your question. Can you repeat?
No, it's not a question. I'm expecting the professional language. In between you're talking in Hindi, we couldn't understand. I'm sorry.
Okay. Sorry, I will take care of this. So what are the good practices? Select the study design feasible to the research question and calculate the sample size before start of the data collection. So this is a very important thing. You have to be very much clear with your study design, and that depends upon your research question, the setup in which you are working, that what study design and the time frame or the money which you have in your hand. So study design actually depends upon these. And then calculate the sample size, because sample size depends upon the study design. Increase the sample size to compensate for the anticipated experimental loss at random. P-value are often too abstract and of limited practical value. Plan to report your result in terms of effect size and confidence intervals. Or use power calculation to plan the experiment, but use a confidence interval when reporting the result. Write up the summary statement explaining your sample size solution, that you are putting the various values in calculating the sample size, sigma, delta. So you have to write down that why you have chosen such value of delta. What are the resources from where you have obtained the value of the sigma, including your assumption and the source of information, and the planned statistical method and decision criteria. So these are the books from which I prepared these slides. Advocacy of Sample Size in Health Research. This is a freely available book. You can Google it and you will find it. Very practical book. All the clinicians should, or all the PIs, all the guide should go through this book. It will help them a lot because lots of examples are, practical examples are also being given. These two books are quite, I will recommend for those who are hardcore biostatician. So they can also go for these two books. So thank you. Now I will be showing you one software, that is the G-Power software. And this software is basically freely available. You can download it, just go to the Google and write down.
Sir, I have one question. Should I
Yes.
ask you?
Yes. So can I just show you this software? After that, you ask this question because this is a very important. After this illustration, just you can ask the question.
Sir, I have one question. Should I ask you?
Just let me show about this software. After that, you ask. I will answer.
Correct.
So this G-Power software is a freely available software. Just in the Google, you type G-Power and click on the first result which you people are going to obtain. So you can see this is the end. Then you can download G-Power manual. It will help you that how you can just put the different values. Short tutorial of G-Power. So these are the PDF manual helpline guideline which you can get. This G-Power is available for Windows and Mac OS. That's why I usually recommend this software because people usually use these two operating. So since I'm using the Windows version, so I simply just click on it, and it is a very small software. So I will simply just download it. Okay. And once I download it, you can just extract it and install it. Okay. So when you will open it, it will like this only. Okay. So you can see that this particular software is looking like this. And as I told you that you have to go for this test. And when you'll go to the mean, you will get different various kind of statistics that you are going to use. Okay, and ANCOVA, MANOVA, Hotling T-square like this. And then similarly for the proportion, if you are using the proportion, then you are going to get all these things. Okay, now I will simply okay, so I'll randomly try to solve such one or two problems from this problem sheet. So you can see the first example. A survey has indicated that the average weight of men over 55 years of age with the newly diagnosed heart disease was 90 kg.
केक पुडिंग बनाते हैं, सेंटा के लिए पूरा तैयारी किए हैं, रूम डेकोरेट। प्लीज जूम इट सर।
Okay. So a survey has indicated that the average weight of men over 55 years of age with newly diagnosed heart disease was 90 kg. However, it is suspected that the average weight of such men is now somewhat lower. Now, this is the research question. है ना? ये research question है और यही problem है. उसको लगा कि नहीं अब तो now it is decreased. How large a sample would be necessary to test at 5% level of significance with a power of 90% whether the average weight is unchanged versus alternative that it has decreased from 90 to 85 kg with an estimated standard deviation of 20 kg. Okay, so this is the estimated standard deviation. Now, for that, if you'll go to the G power, okay, and in this, go to the test mean and one group different from a constant. Okay, so when you will just now the question is that whether it is a one-tailed or two-tailed. The first thing is that whether it is one-tailed or two-tailed. So the answer is that it is a one-tailed because the PI is sure it is decreased. If the PI is unsure whether it is increased or decreased, then it will be two-tailed. So from here you have to select two. But here the PI is sure that this weight is decreased. Okay, so your test is one-sided test. Okay, now what is the effect size D? So for calculating the effect size, you have to determine. So when you click on determine, this new window will pop up over here. Now under the null hypothesis, it is 90. Under the alternative, under the null hypothesis, it was 90. Yes, and now he is saying it is 85. Standard deviation, he is claiming 20. Calculate the effect size D. It comes out to be 0.25. Calculate and transfer to the main window. Click on it. Now this value which is calculated over is transferred to the main window. Your type 1 error alpha is 0.05. And what is the beta which he has been asking for? So beta is 0.95 and then click on calculate. So for this, he require at least 175 patient. Okay. Now here, what is the beta? Beta is 90%. Okay. So instead of 95, just put it 90 and then again calculate. So the sample size comes out to be 139. Okay, so he need at least 139 patient to claim or to test this particular hypothesis. Got it?
Sir,
Now
can
the
you,
another.
sir, can you please explain the graph which it was showing over above? Yes, sir, this red and blue one, sir.
Yes. This actually graph is the for this particular test because it is following the t-test. So you can say that under the null hypothesis, this alpha is the error which is you are being put in. It is the, you can say 0.05, and beta, this type 2 error, it is 90. If you will increase it to the 80%, you can see now this area is being increased a bit more. There's nothing, and then again this alpha is 5% only. Okay. Important thing is this protocol of the power analysis. If you click on it, you are going to get all the input and all the output which you are going to get. Okay. You can just simply copy it and paste. Just copy it from here, Control C, and paste it into your protocol. And you can write down that what is the one tail and what is the effect size D. Now this is 0.25. How this effect size is calculated, you can just explain it here. Alpha error, yeah, type 1 error is 0.05 and your beta is 0.80. So if your power is 0.80, your sample size is 101. Okay.
So this software is only used for the sample size determination?
Yes, this is only especially for the sample size.
Okay, sir.
Okay. This G power is there. So similarly, if I will take one more example, just this problem number 5. During a virulent outbreak of neonatal tetanus, health worker wish to determine whether the rate is decreasing after a period during which it has rise to a level of 150 cases per 1,000 live birth. What sample size is necessary to test? H0 P is equal to 0.15. At 0.05 level, if the desired power is 95% probability of detecting a rate 100 per 1,000, if that were the true proportion. So 0.15 से 0.10 हो गया. So we are in the process of testing this proportion. Okay. So instead of mean, now we'll be testing the proportion. So for going to the test and then going to the proportion and one group difference from the constant. This is again the one tail because they are saying that 0.15 से 0.10 हो गया. Determine G. So difference, it is 0.15 से 0.10. Okay. Calculate and transfer to the main window. This alpha is 0 and this is 0.95. Constant proportion is this. Then calculate. So for doing this, you have to choose at least 474 neonates for estimating whether this is being decreased or not. Okay. So in this way, this particular software, which is freely available, you can simply download it and also go through the manual. You can lots of YouTube videos are also available that how you can do the sample size calculation with this G power. My main motive was to just let you people tell you that sample size calculation is a very important part of any study which are being taken up. But the way we are doing is not correct. So just this will alarm you, or this will just awake you that you should be very much careful while doing the sample size calculation. It is very easy, very logical, but we are not practicing it in a correct way. I usually say that we are practicing our clinical practice in a very correct way, but we are not practicing our research, doing research in a quite clinical way. So doing research in a clinical way is also the need of the hour for all of us. So with this note, I will just end my talk, and the session is open for question and answer.
Yes.
Good evening, sir.
Yes, please.
Sir, this is Madhavi. I am a PhD student. Sir, I am planning to go for hospital-based case control study. Can this software be useful for me to calculate the sample size for a particular disease? I would like to work on gastrointestinal cancer patients, sir.
Yeah. Here you can see the if case control study. So in this here you can see that you should have an idea about the odds ratio.
Yeah.
So by this you can calculate this effect size G and then alpha and beta. Look, I already told you that the sample size calculation actually depends upon whether you are in the process of estimating something, or whether you are in the process of testing a hypothesis.
Yeah.
Okay. Accordingly, the sample size formula will come into the play. So this is not the only software. There are various softwares.
Okay, sir.
For calculating the sample size. The formulas are already there. Thousands of formulas are there. But which formula will be suitable for you? So you have to discuss with some good statistician, and he will definitely suggest you that how you should proceed with your study design, and how you should what sample size formula you have to use, and then what statistical calculation you have to perform when your data is being collected. So
Okay, sir.
very difficult to answer. Within this information, it will be quite difficult to answer.
Okay, sir. Yeah,
Sir,
thank you,
any
sir.
software available in Linux for sample size calculation?
R. You can use R for doing sample size calculation with the Linux.
Thank you, sir.
Sir, one idiot question. In power analysis, what you have shown, we can have written n small in a small n, that is sample. Okay. But when we experimental group and control group, so that n will be only denoted to experimental group 30, and whatever the sample type will be n
No, ma'am.
in experimental group, and then
Just look at this test, and then when we'll go to the mean, there are when there are experimental, so you have the two independent groups. Okay. So when we'll calculate this,
yes.
you have a sample in group 1 and sample in group 2. Okay. So in this way, in this way, total sample size will also come, and how many sample in group 1 and how many sample in group 2. You can also allocate that whether the allocation is 1 or 1:2. If we'll put 2 in one, it will be 30, another one, it will be 60.
Okay.
So for that also, the formulas are different.
Yes. Quantitative study.
Yes.
Okay. Thank you. The lecture is very nice. I liked. Very good explanations. Thank you.
Thank you. So, Dr. Dharmendra?
Yes, sir. If participants, I think there are no more questions. If they have, so kindly, sir, share your this email so that the participants can directly reach to you if have further queries regarding sample size.
I just sharing my email, and
So you are also requested to share this PPT so that we can.
Okay. Just, yeah, you are right. At this point of time itself, I will. I've shared it, Dr. Dharmendra.
Oh, sure, sir.
I've shared it. So I hope this workshop will help you a lot, and wish you a grand success in this workshop. So should I leave?
Okay. Thank you, sir. Thank you. Thank you. Sir.
Okay. Thank
Thank
you.
you.
Thanks a
Thank
lot.
you.
Thanks a lot for giving me this opportunity. Thank you.
Thank you, sir. Thank you for this. Thank you, all the participants.
Thank you so much, sir.
Okay.